We know we can never have it all. Never. But yet, can we ever, in endless scarcity, have just enough? 2, 6, 4. These are the last digits of pi. That's quite a statement, isn't it?
That is a statement.
So the world record, current world record, March 2022, the world for the computation of the digits of pi is by the applied sciences team at Grisons, the Davis team, and they calculated 62.8 trillion digits of pi. It took them about 108 days at an average speed of about 6.7 million digits per second. Pi starts here, and then much later, much later, you're looking at, I think, 800. The last 800 digits of pi here, it ends in 264, and hence the name of the track, 264. Or perhaps the ellipsis should be after or before. We don't know. So how are we playing this track? This is a really fun one. It's the end. It's very energetic. And the idea is to take the digits, and we're mapping them onto a couple of scales that Greg will talk about.
I was just kind of messing around with pentatonic scales. And I realized that if you play a C major pentatonic scale, so that's C, D, E, G, A, and then played an E flat minor pentatonic scale, so that's E flat, G flat, A flat, B flat, D flat. If you put those two pitch groups together, you come up with this decatonic scale. Happy, happenstance, coincidence. It was kind of like one of the driving factors between composing this piece, behind driving this piece.
So if you remember, the length of the computation was 0.591 seconds. So what we've done is we've written a piece that represents the last 119.591 seconds of computation. We picked 119 because it's a 2-minute long piece, and that seems like a reasonable length of time. But the 0.591 is actually quite significant. So we looked at the last billion digits of pi, and we chunked them into 6.7 million digit windows. Every second you get 6.7 million digits. So we looked at inside each of these windows of digits, which you see here, and we play the first and the second note in that window. We then play the mode, which is the digit that is seen the most often. We play that twice. And then we play the penultimate and the last. So for example, for this 1 second window, we would play a 9, a 1, a 5, 5, a 9, and a 6. We would look them up here. We would play a B flat, a 1, we'd play a D flat, and so on. And we go up until the very last bar, which is a fractional bar, because remember that 0.591 seconds. And that is about half a second. So if we play 6 notes in a bar, that gives us 3 notes in this fractional bar. This is all working out so nicely. We play the last 3 digits, 264. And I do want to thank Thomas from the Davis team. He actually sent us a recording of the hard drives that the sound that they make when they spin up. And this is incorporated into the MIDI realization of this track. You will hear in the track the sound of the hard drive spinning up to perform this computation and then spinning down at the end. So this is our score. Relentlessly computing. This is how you should play it. And the right hand is those 6 notes, and that is 1 second of computation.
Yep.
And that is the next second of computation.
Correct.
All the way to the last fractional second.
Yeah.
So we don't have a choice of what notes to play. Those are determined by the digits of pi, and they're going to be random with the exception of that mode, which is played twice, that third and fourth note. So there's a little bit of a pattern there.
There's a bit of repetition, which becomes more apparent towards the end.
Yeah. But what's happening in the left hand?
I just want to talk briefly about the right hand. So because of the nature of the scale that we've chosen a 10-note scale, which is all but 2 notes of the full chromatic scale. So when we map the digits of pi onto this 10-note scale, your ear is hearing essentially a very chromatic sound, which means that it doesn't have a strong tonal center. It just sounds like a string of random notes, even despite having these repeated notes. So the right hand is very deterministic, and it doesn't alter. We can't change it musically. So that just meant that I had to focus purely on the left hand. And I decided to kind of continue with this pentatonic idea. So the very first chord, we can hear these two pentatonic scales, the C major pentatonic and then the E flat minor pentatonic. We hear that as a big tone cluster at the start, which doesn't sound like any kind of chord. It just kind of sounds like a noise. And that kicks off the computation. From there, in the left hand, we have a C major pentatonic chord in various kind of inversions, all accented, and at various kind of rhythmic displacements throughout the bar. So it's not really giving you a sense of strict kind of meter. It's a bit more random than that. The idea behind the left hand was to make it sound like the left hand of a jazz pianist. This is a very kind of common technique that was developed in around the 1940s, 1950s. The left hand is delineating a harmony or a chord, and that modulates or changes key every 10 bars. So here we've got 10 bars of C, and then we are modulating to, let me look at that, we've got our E flat minor pentatonic. That continues for another 10 bars until we go back. So that happens for 100 bars. We've got 10 different key changes, one for every note of our decatonic scale. I've kind of moved through in chains of thirds. So we go from C to E flat to G flat to A, etc., through the scale. And when we get to bar 101, then we come back to this idea of simultaneously hearing C major pentatonic, E flat minor.
So if we move through the score,
yep,
I noticed I did not put bar numbers on it.
That's okay.
That is my fault. So we're going to have to hunt for bar 101. But you're saying that the left hand harmonization is kicking in a little bit more. There's more things that are being played.
Yeah.
It's fuller. There's fewer rests.
It's becoming more melodic. So it starts off purely as rhythm with these chords, and then you can see it's kind of building up through these melodic ideas, which increase until in the last kind of 20 bars, just hearing continuous eighth note runs with these chords.
And we're doubling up the right hand,
indeed,
an octave up. So
yep,
that gives it the sound a little bit more thickness.
Yeah. So towards the end of the piece, you'll hear these marcato octave. Representing the mode of the computation, and that really kind of gives the piece a sense of drive and culmination towards the end. And
this is the 0.591 seconds, 264,
essentially half a bar,
and then the rest is to be computed.
For sure. ...
Yeah. So one final point: the tracks that you'll be hearing are not performed by a human being. They were MIDI realizations. Greg, do you want to talk about the process behind creating these?
Yep. So unfortunately, due to time constraints, we weren't able to get these pieces in the hands of a pianist for them to record and perform the piece. So the next best thing is to create and design these MIDI realizations, which was kind of fun for me. And they really kind of give a good sense of what the pieces are, how they're supposed to sound. I think there's enough kind of musicality. I spent a lot of time designing, velocities, different velocities and kind of tempos and things like that. So hopefully it doesn't sound too artificial and MIDI-like to your ears. So the idea was that if you heard it on the radio, your ear would be kind of tricked into thinking, oh, that's a real pianist.
That's a real pianist. Yeah. It's the Noir.
It's the native it's the native instruments Noir piano library. I can 100% recommend it. It's a beautiful sounding piano, and it's thoroughly sampled by Niels Fram and his minions. in Funkhaus in Berlin. So
this is our last track,
is the final
and
track.
this has been such a fun project. I have learned more than I ever thought I would learn in such a short period of time about music, about composing, or at least being next to a composer, engraving music, producing music, and thinking about music, and then speaking about music.
Yeah.
And I worry that I don't know yet enough to actually make such videos as these. Please, if you are a performer, we would love to hear your interpretations of some of these scores. Please reach out. Leave your comments about what you think of the music, what you think of the approach, maybe what you would have done differently. This would be a fantastic conversation to continue.
Yeah, absolutely. So the PDFs of the scores will be available for people to download.
The PDFs will be available.
Yeah. So you can take it home and practice and kind of mull through the pieces as you wish.
And we'll make the audio available as well on a variety of streaming services. So
it'll be available on Spotify, Tidal, Bandcamp as well. So we hope you enjoy our conversation, and hope you enjoy listening and performing the pieces.
And it would have been lovely for Emma to have been here. She cannot be here, so all we could say is, can we ever in endless scarcity have just enough?